So thank you, friends. Here we have Stephen and Matthews.
All right, thanks. So we're here to hear about SniffAir, a tool that we designed for wireless penetration tests. Go ahead, kick it to the next one. The obligatory who are we slide. Stephen Darracott, Matt Eidelberg, aka White Shadow, aka Tylus. We work for a little company called Optiv where we do all sorts of pen tests ranging from network security or network pen tests, physical security, wireless security. Out of all the people on the team, there's only a handful that could call themselves really wireless specialists. And you have two of those people up here for you today. We can go ahead and roll into the next one. So what is SniffAir, right? Jackie Chan wants to know. We'll go to this next one. All right, so the idea of SniffAir was born from the hassle of having to deal with large amounts of data on our wireless penetration tests. You know, we test a lot of big name companies, sometimes have 20, 30 stories of a building, and we go through and we do a network capture for each floor. Now, parsing through that data basically just became a huge pain in the ass. So there's a number of things that we have to go through all these PCAPs and pull out, like number of access points, probing clients, what are they probing for, things like that. And the kind of the old school way of doing things was with Python scripts, right? I mean, you had a Python script that go through and pull out one specific thing from your network capture, or you just pull it up in Wireshark and take screenshots of the information you're looking for. So what we wanted to do was make one tool to use for all of that. So you can go through and look at your data easily, pull it out, and analyze it that way. When we were coming up with the tool, we realized that the data that we were pulling out could also be leveraged in the attacks that we use during our wireless penetration test. So kind of building on that as well, we were like, okay, so if we're going to launch attacks, what would be a good way to do it? So we decided to go with a modular framework, something that people in the community are familiar with tools like Metasploit, PowerShell Empire, things of that nature. And I will stop talking about the tool, and Matt's going to show it to you.
So first, how does it work? Like Stephen said, it uses PCAPs, but it also can use live capture data in real time. And what it does is it runs each packet through a comprehensive fingerprinting system that we built using Scapy. The tool first identifies what type of packet it is and groups it together. So that would be either an access point packet, like a beacon frame, probe request, probe response, or anything related to enterprise user credential password passing. Once it's grouped them, it parses each of the packets and pulls out the important data. That could be the channel that the access point sits on, the encryption, the authentication method, the MAC address of the access point itself, and stores only unique strings. As we all know, beacons, cell phones, laptops, they constantly are sending out many of the same type of packets, almost identical. So we only care about the one copy of each. So we could talk more about it through slides, but why don't we just show you how the tool works? So first thing, you would create a workspace, and that would be a database that you can store all your data in. In this case, we've actually already done that, so we're just going to go ahead and load it. Once it's loaded, you can actually see the identified ESSIDs so far. Now, we have many tools built in, which we'll discuss more, that allows us to discover further ones. Well, right now we're going to talk about a table that we as pen testers find very valuable, and that would be the access point table. Just going to scroll up. So in this table, you can see the ESSID, the associated BSSID, which is the MAC address of that access point, the vendor who built it, what channel that access point is sitting on, the power. And the power denotes how close you were at any given point to that access point. SniffAir only cares about the lowest value, so it would be the smallest value, because that indicates how close you were. Higher values mean you're farther away, and that doesn't really help you. As well, the type of encryption, is it open, is it WEP, WPA, WPA2? What type of cipher is used, as well as is it private key or management using EEP?
All right, and then another useful table that we use as pen testers, or could utilize as pen testers, is the probe requests table. Yeah. So what this shows is communication between a client and a potential access point. So what a probe request is say you're at home or you're at your friend Bob's house, right? You're using Bob's Wi-Fi on your phone. When you leave Bob's house, your phone is constantly sending out these messages saying, hey, where's Bob's Wi-Fi? That's a probe request. So even if the access point isn't there, your phone is still going to be broadcasting that message out. So we can leverage this type of information here in a number of ways. One is hidden SSIDs. A lot of people don't realize that when you hide the SSID of an access point, the client is broadcasting that in the traffic and can be seen by anyone. So hiding an access point doesn't do you anything at all. So we can actually see that in these probe requests. When we see a client that's sending out a probe request for a network that we don't see, but we see a lot of hidden ones, we can assume that it's probably one of those. And we'll get into that a bit later. Also, what we've seen on pen tests is typically when clients have a hidden SSID configured at their office or workplace, sometimes people don't know how to set that up on their device, and they will actually put in the pre-shared key or the password for the network as the hidden SSID. So when we're looking through these probe requests, we see one that looks really weird with a bunch of special characters and stuff. Yeah, that was probably the network password, and we've seen success with that on numerous engagements. The next table we're going to talk about is the probe responses. So probe responses shows association between an access point and a client. We can leverage this as pen testers in a few ways. If you're standing up, say, an evil twin and you want to copy an access point, you could see exactly which clients are connected to that. So you know what clients you're looking for. You could even take that a step further in your evil twin and set up maybe a MAC address, whitelist, blacklist, something like that, so that you only get the clients that you want to man in the middle with your evil twin. All right, and now I'm going to hand it back to Matt, who will show you another table.
Okay, so this is the EEP table, the enterprise table. So this table collects and stores information pertaining to usernames, as well as the source address of devices that send said usernames. The interesting point and why as pen testers we should be caring about that is with EEP, PEEP, those type of networks, the usernames are sent unencrypted before any encryption with regards to the password is sent. So right there we can see clear text usernames, which we can facilitate for further attacks, which we'll discuss further down the road.
Right, and that's another thing like the hidden SSIDs, right? A lot of people don't realize that you're using EPEEP encryption, just like a lot of people don't realize that their hidden SSIDs are being broadcast by their clients. With EPEEP encryption, usernames are going across over the air before that actual encryption tunnel is set up, as Matt just mentioned. So aside from these, we also have a couple other little queries that we've put together. So show the AP MACs. This is all the MAC addresses of all the APs that you collected on. Showing the vendors is an easy way to pull the vendors out. This is good for rogue detection and things like that. If you have 150 Cisco access points and you see one Linksys or D-Link that's broadcasting the same SSID as your other ones, it's probably a good indication it's a rogue access point. Also, we have the usernames. Just as Matt just showed you how we can pull out the EEP information, we can actually pull out just the usernames themselves, which is easy to copy and paste into whatever kind of attack you're trying to launch. Aside from these that are pre-built in, we also put in the functionality for users to create custom queries. So we're using a SQL database on the back end. SQL is a very easy language to learn if you don't already know it. A lot of people in the community are very familiar with it. And so, like Matt just showed you, you can just run a SQL query and query the information that you specifically want from our database. All right. The show models, want to show the in scope? So another thing that we did, in order to facilitate tactical precision in our tool here, mass collection of data is easy, right? Now mass sorting through that data isn't. So what we created was a scope. And you can actually add one specific SSID to a scope and then show it. And you can actually add multiple SSIDs into this scope. So there's an easy, good picture for a screenshot and a report, all based on the in-scope table. So now, as Matt showed you, the show modules command, we actually have attack modules built in. And one of the modules that we're going to show you real quick is to uncover hidden SSIDs. Now, I talked to you about earlier how clients, probing clients, are actually broadcasting the name of the SSID if it's hidden by an access point. Since this is all passively collected or Yeah, passively collected information. We're doing this passively. We can uncover hidden SSIDs just based on the data that we've collected. So go ahead and run the module. And so this is what I was just talking about, how we saw those clients that were probing for specific access points. We referenced other tables and said, hey, this access point was hidden. Well, so if this client is probing for this hidden access point with that name, it's got to be that. And so we can uncover them. Another tool, or after you've done this, this all gets stored in a hidden table. So you can pull up the show hidden table. Oh, yeah.
Sorry. It's a table, not a query.
Yeah. SSIDs. There we go. So now here's kind of a broken down list of that. Now you can take that list. You know those were hidden SSIDs that you walked by. So you now have a word list you could apply into additional attacks and uncover more that possibly you didn't collect passively. You could then actively send out those probes and unhide those SSIDs. So now we're going to talk about another attack module. And since this is B-Sides, we didn't want to show you guys something like cracking WEP or WPA. We didn't want to show you the MS08067 of wireless. So we actually brought a unique attack, unique to us, that was built from the ground up by Matthe Eidelberg himself. And he's going to show that.
So we have a video of it because this is B-Sides. We didn't want to have people indirectly connect to it and target them. So this tool is called AutoEEP. This tool is an automated wireless brute forcing. And so we made a video of it. So as we go through, we'll discuss it. So as we saw before, we loaded up the workspace. But what AutoEEP does while this is setting up is it performs EEP and PEEP level authentication checks and checks for response, success, or failure packets. So you can see right here, we've discovered a management access point broadcasting the ESSID honeypot. Now, if we take a look at the table EEP, which stores any possible usernames, we can see a series of usernames, and they've connected to that BSSID. That BSSID, in turn, maps to honeypot. So we know that all these users have connected to honeypot. So using this information, we can then load up the module, AutoEEP, and set the appropriate variables. So for each one of the attack modules, you can actually set up the SSID, the channel, if you wish, interface, as well as the various specific configurations for each attack. So captive portal would be what type of web page you want to masquerade as. Evil twin, do you want it to be enterprise, WPA2, what have you. So once it's been set up, you can then select what type of password you want to feed it. Now, another option that we can do, as you can see with the info, is instead of using the DB stored usernames, you can actually specify a file. So there are many tools, Harvester and other underground ones on GitHub, that allow you to enumerate other types of usernames. Unfortunately, it's a little cut off. But what this is now doing is it's explaining. So it spins up its own WPA supplicant and generates these packets and requests.
Video's not running.
Oh.
There you go.
Spinning up, looking for those success or failure packets. And once it's detected them, it will record and log and store the successful and failed attempts. Fortunately,
it's getting cut off by the
yeah.
task. Fast forward it a little bit.
Yeah, I'm going to fast forward it just to kind of see. So can everyone see? I know it's a little cut off and it's at the bottom. But you can see we've had several successes and failures. And we can now use these credentials for other attacks, not just specifically for logging in through EEP wireless networks. We can actually use this to log into, if the client has a Citrix VPN publicly facing, we can log in. We can access the Outlook web portal using these credentials and gain access or lateral movement through those different attack vectors.
All right, so to summarize this tool, parses data that you import, whether PCAP or live capture, and allows you to easily parse through that data and pull out what you need. So, and we did that with queries, and we also added attack modules. And we also have custom queries so that you don't have to just deal with what we made. You can also run your own queries as well. And yeah, we've already touched on the modules as well. So the next slide is our future stuff we look forward to doing. More attack modules, obviously, than the ones that we showed you here. Post-X modules. So once you get on the network, what do? We plan on implementing things like responder and things like that, just so we can have some kind of post-X in there as well. Implementing reporting modules, so more reporting to make it easier for screenshots and stuff like that. A lot of the tool is based on pandas within the Python library, and that's there's a lot of features within pandas that allows you to graph things easily that we haven't really touched yet, and we could definitely improve on that as well. Yeah, and that's about it. There's the GitHub. Are there any questions for us? No?
No questions?
All right. Oh, good question. That is
an O. The GitHub is, there's no numbers in the GitHub for that one.
We'll move that way. One more?
Right there.
Oh.
So you mentioned that you were using SQL on the back end.
Yes.
Have you done any hardening to make sure that Wes McGrew doesn't make allergy error next year?
No. No, we haven't built any kind of security into it or anything. I mean, you think when
outside
you're
of the databases being encrypted, there's
obviously
nothing.
But yeah, when you think about wireless attacks, you're typically separated from a network on your own. No one's connecting to you to exploit your locally running software, supposedly, hopefully, right? So no, question. But yeah, it's definitely a future feature that we could definitely include, right? Yeah.
Any more questions? Cool. Thank you. Thanks, Steve. Thanks, Matthe.